So in this little podcast, I want to go and start playing around with the fact that we can start changing logarithms into exponents. Because basically, a logarithm is an exponent. Hmm. Basically, because that's a base, you can take a log and make it an exponent. Remember? You can take any log here. There's c to the power of y gives you x. C to the power of y gives you x. Right. So with the next couple of examples, that's all I want to do is I want to convert the logarithms into exponential form. So, okay, there's our base. Base to the power of 5. Look, 2 to the power of 5 gives you 32. And no kidding, 2 times 2 times 2 times 2 times 2 is 32. Now, check this out, though. Oh, this is even more fun. What if our base is a fraction? So what? So what? Think about this. Isn't this 1/3 to the power of -4? And if you remember what that means, that negative means to flip it, 3 to the 4. And isn't this just 3 times 3 times 3 times 3? 3 times 3, 9. 3 times 3, 9. 9 times 9, 81. There it is. Shazam. So what I just showed you then, ladies and gentlemen, is this. I showed you a way of solving. Okay. So how do we solve? What if I didn't tell you what the log equaled to? What do? Well, first thing is I would say, okay, let it equal to any value. Let v be value. All right, so you represent log 2 of 8 equal to v with an unknown value of v. Then you'll go 2 to the power of v, right, equals to 8. Right? So what you're doing here is you're changing this into exponential form. So change to exponential form. Oh, that's easy. But watch this now. This is really cool. You see the 8? Can't you write 8 as a base of 2? So what you're going to try to do is you're going to try to get the same base. So convert the number here, convert the number to the same base. Okay. That's cool. And now, check this out. Ready for this? You know and I know things that are like on opposite sides of equal signs, they cancel, leaving you v equals to 3. So cancel the common base. There it is. If you cancel the common base, you get the answer, which is 3. So log 2 of 8 is 3. Prove it. Prove it. Sure. 2 to the power of 3. That equals to 8. You can always go back into exponential form and figure it out. So with this kind of idea here, folks, I want to go through this chart. Interesting. That's some really cool stuff to play around with. And I did log 2 of 8 right off the bat. Notice that we're not dealing with common logs anymore. I'm not dealing with a log base 10. I'm now dealing with a log base 2. Who cares? Just remember, 2 to the power of 3 gives us 8. Ta-da. So this would be 2 to the power of what? Well, if you want to use v, go ahead and use v. 2 to the power of v has to equal to 4. But do you know that 4 is just 2 squared? So this makes this then 2v equals to 2 squared. Cancel that, cancel that. Look at that. V equals to 2. There's your answer. Okay? And you can prove that by saying 2 to the power of 2 gives me 4. After a while, you'll be able to just look at it and figure it out. Same thing with this. Put it down as a value if you want. 2 to the v, okay, 2 to the v has to equal to 2. Oh my goodness, what value, what exponent of 2 gives me 2? This is 2 to the 1, look at this, v equals to 1. So you could actually write this out as an exponent now. 2 to the power of 1 is just plain old 2. That's just starting to get too easy. But how do you do this? 2 to the power of v, right, has to equal to what? Wait a second. How do I make a common base out of that? Well, it's really quite simple, actually. what you're going to do here, and you have to remember grade 9 math. Any base to the power of 0 is 1. Oh, cancel that out. V equals to 0. Ta-da! Super simple. Same thing goes when you're dealing with fractions. 2 to the power of v, right? Think about it. 2 to the power of v has to equal to 1/8. Flip it. 2 to the power of v has to equal to 8 to the minus 1. Okay, right? Now, 2 to the power of v equals to 8 to the minus 1 means that this is 2 to the v. 8 is 2 cubed. 2 cubed to the minus 1. Ah, that's got to be 2 to the minus 1. So, guess what? This answer for this guy then has to be minus 3. Cancel the 2's. V equals to minus 3. Yep, works perfectly every single time. Take a look at the next one. Same idea, right? There's your base. So you're going to write this as log base 2, right? Log base 2 is going to equal to negative 2. And what are you going to take the log of? You're going to take the log of a quarter. Think about it. 2 to the exponent of negative 2, 2 to the exponent of negative 2 is going to give us our original value. Same thing goes with this. There's our base. Log base 2, right? Okay? Think about it. It has to equal to that exponent. So 2 to that exponent of negative 1, there's the argument. 1/2. Isn't that neat how that works? Then let's keep on going and see if that actually makes sense and burn this into your brain here. Watch. Same thing. There's the base, exponent 5. 3 to the power of 5, 243. Do it again. 4 to the power of negative 4. 4 to the power of negative 4 has to equal to 1 over 256. Think about it. That negative automatically tells you that this guy's got to be 1 over 4 to the power of 4. 4 times 4 times 4 times 4 is 1 over 256. Huh. C to the x. Oh, this is just kind of an algebra one. Equals to a over b. Oh, how lovely. Okay, keep on going. Look at this. 7 to the power of x. See how we can get rid of the logs really nicely? There we go. Keep on going. Look. 5 to the power of x equals 7y. This is how all of these work. There's just no doubt about it. They're just very, very, very easy things, very, very easy functions to play around with. Okay? There's nothing really matters with a lot of these things. Now, I do have to say one more thing, though. I don't know about you, but I don't like something with the y. It's not a y equals 2, is it? So get rid of that thing on the bottom. Multiply both sides by 3. So this is going to be 3 times 7x. Oh, that's prettier. I like that one. Same goes with this one. Get rid of that 7. Divide each side by 7. So you can just write it as 1/7 times 5 to the power of x equals to y. Just nicer to get that y by itself, right? Okay. Important point, though, is this. Do you notice that I did not multiply 3 times 7? Remember, bad maths. Bad maths, you learned that way back in grade 4, says exponents are separate from multiplication and division. You can't go out and multiply that because you haven't done the exponent yet. So make sure to keep them separate. All right? All right.